Okay, so I don't know about you guys, but I certainly prefer the second derivative test over the first derivative test. It's much faster. So the big question, again, how do you know if your critical point is a local min or a local max? Well, step one, set f prime of x equal to 0 and solve for x. That determines whether your point has a horizontal tangent line. Now, you want to figure out whether it's a local min or a local max. So you plug in that critical point's x value into the second derivative function. In other words, you use the acceleration to predict the velocity. So if your f prime of x is positive, that means that it has a horizontal tangent line, but it's psychic enough to know that it's about to go up. So if it's a horizontal tangent line and then it rises, that means it's a local minimum. So instead of using the first derivative test where you say negative slope to 0 slope to positive slope, you could just say the second derivative is positive at my critical point. That's enough information to say that that's a local minimum. F prime of x is negative, so the opposite, as opposed to doing the first derivative test where you test out the critical point horizontally and then to the left and to the right go from positive to 0 to negative, you can just say that if f double prime of x is negative, that means that it goes from a horizontal tangent line to a negative tangent line. So those are the properties of a local max. Now, the third one, one of you guys sent an email to me, thank you very much, to you-know-who. You asked, well, is it possible for f double prime of x to equal 0? And I replied saying yes. In fact, that was going to be the next video. But specifically, it's inconclusive. I misspoke when I said it's automatically a saddle point. There's many different types, but the point of the matter is that it's inconclusive. And the best way I can show it is, let's say the graph rises, flattens out to a horizontal tangent line, and then rises again. Well, if it rises, stops, rises, that's not a maximum point. If it lowers, stops, lowers again, that's not a minimum point. That doesn't make any sense. So we just call it, it's not, the key word is not inconclusive. I just say it's either a local min, a local max, or inconclusive. So if the second derivative is positive, local min. If the second derivative is negative, local max. If the second derivative is 0, we don't know what it is. Okay? So then, let's get some problems in. Let's find all the local extrema for f of x is equal to 27x minus x cubed. Okay, so first things first. I'm gonna set it all up in advance. I like my f prime of x and my f double prime of x. So I'm gonna put them all at the top, and then we'll refer to these later. So first things first. It's in reverse. I'm aware. The book gave us this problem, this glorious book over here. This calculus book gave us a problem where it's 27x minus x cubed. Don't worry, we can still take the derivative. What's the derivative of 27x? 27. What's the derivative of negative x to the third power? That would be negative 3x squared. Then, just for the heck of it, let's do the second derivative. Well, the second derivative of 27 is going to be 0. And the derivative of negative 3x squared will be negative 6x. Okay, so now, let's solve for that. Let's solve for those critical points. So first things first, let's set f prime of x, aka I got the position, velocity, and acceleration. Let's take the velocity function, the first derivative, and set it equal. Yeah, I did it correct. I was looking at this one. I was like, did I do this right? I was like, no, I did this correctly. And set it equal to 0. Okay, well, if you don't mind, I'm going to reverse this and say negative 3x squared plus 27. That's going to make me feel a lot better. And I'm going to factor. Specifically, I'm going to factor out a negative 3 because it's not my first rodeo. Negative 3 times x squared will be negative 3x squared. And then negative 3 times negative 9 will be positive 27. And you see why I did that? Because then I can go back to Algebra 1 and do some factoring. We need to factor, let me just highlight this over here in green. I can factor x squared minus 9. Those are that's the difference of two squares. I can factor them into conjugates. So we factor x squared minus 9 into the difference of two squares into conjugates. X plus 3, x minus 3 equals 0. So what this means is that my critical points are located at x plus 3 is equal to 0, or x equals negative 3. And my other critical point, x minus 3 is equal to 0. Let's just skip right to it. X is equal to positive 3. So I'm going to leave space, and I'm going to use my second derivative to plug into here and see which one is which. So let's get on to it. So remember that, oh sorry, my paper's flying all over the place. F double prime of x is negative 6x. I like that. I'm very happy about that. Not too much. So now let's plug in f double prime of negative 3. And then f double prime of positive 3. So if I plug in f double prime of negative 3, negative 6 times negative 3 is positive 18. Hey, I like that. Well, just the fact that it's positive. The acceleration is 18. You can do whatever you want. But the fact is, if the acceleration is positive, that means it's about to rise. So if it's a horizontal tangent line and then it starts to rise, those are the properties of a local min. Okay, let's go over here. Let's plug in f double prime of 3. So we plug in x equals 3 into the second derivative, and negative 6 times positive 3 would be negative 18. Oh, well, you know, another 18. But all I care about is that acceleration positive or negative? That acceleration is negative. So if it has a horizontal tangent line, and then it's about to go down, I'm not going to yell timber. I'm going to say that's a local max because it has a horizontal tangent line and then it local max. There we go. So x equals negative 3 is a local min. X equals positive 3 is my local max. Let's check with the graph on Desmos. So let me get that up here. I want to go home. There we go. Well, I'm already home. Just wanted to go home to the 0, 0 part. So yeah, just to show the graph, it really zooms out, and you would plug in x equals negative 3 is a local min, specifically located at negative 3 comma negative 54. And x equals 3, y equals 54 is a local max. So really what we care about are the x values of the critical points. And just like that, that's exactly what our math said. Okay, moving on to problem number 2. This one has a fraction, but we're not afraid of it so much. F of x is equal to x cubed over 4 minus 3x. Find the x values of the critical points and determine whether they are local min or local max. Okay, so what's our first move? Well, part of what unnerves me is that x cubed over 4, so if you don't mind, can I write this as 1/4 x cubed? Yeah, I can. So I'm going to rewrite this as 1/4 of x cubed, okay? Or you know what, if that makes you feel any more comfortable to write this as a decimal, be my guest. That would be 0.25 x to the third. Be flexible. Okay. So now, I like to take my derivative, f prime of x. Not too bad, not too bad. The derivative of 0.25 x to the third, well, that'd be 3 times 25 cents. That'd be 75 cents x squared. And then minus the derivative of negative 3x is 3. So now, I'm going to set that well, first, well, let me actually take the second derivative while I'm at it too, because I like it all in one place. So the derivative is 0.75 x squared minus 3. So the derivative of the derivative would be double 75 cents. That'd be $1.50. X, 1.5x, and the derivative of negative 3 is gone. So I'm going to put those, I'm going to refer to these, any one of these for f of x, but I'm a decimal guy, so I like decimals. So what we do is we set f prime of x equal to 0. So that'd be 0.75 x squared minus 3 is equal to 0. Well, let's see what I can do. Can 0.75 go into 3? I'm not sure. Let's because I'm always exploring my options. 3 divided by 0.75. Because if I can factor out that 0.75, that'd be awesome. Oh, I can. Oh, that's. Oh, I didn't even plan that. That was amazing. I'm actually impressed. So if I factor out that 0.75, now I know why that problem's up there. 0.75 gets factored out, leaving me with x squared. And 0.75 times negative 4 would be negative 3, which is equal to 0. Ah, factor. Oh, the proof is in the pudding. Well, there's no pudding. There's only calculus. So we factor x squared minus 4. Factoring never goes away. So if I factor x squared minus 4 into conjugates, that's going to be x plus 2. X minus 2 is equal to 0. Now I can factor using the zero product principle and state that the critical points lie at x equals negative 2 and x equals positive 2. But now we need to determine whether they're local min or local max. So what do? We look at the second derivative and we plug them in for each individual piece. So remember that the second derivative, I just don't want to keep scrolling up, is 1.5x. So I'm going to use the second derivative test to determine, hey, what's the behavior? Behave yourself. F double prime of x is 1.5 times x. So we plug them in. Let's start with, since we did the left problem last time, let's do the right problem. F double prime of x equals 2. So f double prime of 2. 1.5 times 2, $1.50 times 2 would be 3. That's nice. So the critical point means that it has a horizontal tangent line at x equals 2, and then it rises. Those are the principles of a local min. Then, let's plug in x equals negative 2 for the other critical point. 1.5 times negative 2 would be negative 3. Okay, I don't really care so much about the 3, but I do care about that negative. So the critical point means that x equals negative 2 has a horizontal tangent line, and it's about to go down. So if it has a horizontal tangent line and then it goes down, those are the properties of a local max. And just to check, let's graph it. Zoom in. X equals negative 2 is a local max. X equals positive 2 is a local min. All right. Okay, next one. X cubed. So f of x is equal to x cubed. How harmful could x cubed be? Well, let's just get everything organized. We've got our f of x. Let's take our f prime of x and say that is 3x squared. And while I'm at it, let's take f double prime of x. What is f double prime of f double prime of x in this case? It's the derivative of 3x squared, which would be 6x. Well, let's get this show on the road. So now I've got my f of x, my f prime of x, my f double prime of x, my position, my velocity, my acceleration. Let's go. So now I'm going to set f prime of x equal to 0. Well, you can kind of see this one coming a mile away. Even if I divide both sides by 3, x squared is equal to 0. I mean, there's nothing really exciting here. X is equal to 0. All right, well, at least I've got my second derivative. My only critical point is at x equals 0. Remember that f double prime of x is 6x. So now I'm going to test it out with f double prime of 0. Well, 6 times 0 is 0. Okay, so my tangent, my critical point has a horizontal tangent line, and then my acceleration is 0. Well, I can't really go anywhere. It's inconclusive. So, just to show you in a graph, and I'm playing along, by the way, if you look at the graph for x cubed, you'll notice that x equals 0 is the, from the left side, it rises, and then it flattens out. There's a horizontal tangent line there, and then it rises again. That's not a maximum point, because it doesn't rise, stop, rise again. It rises, stops, and falls. So this doesn't really make a lot of sense to us. We just call it inconclusive. It's neither a local min nor a local max. Okay? All right. Number 4. F of x is equal to x squared plus 4x plus 4 times x minus 1. Memories. Memories. Oh boy. Okay, so, well, to find f prime of x, remember that this is a product function. Now, don't get me wrong, you could FOIL this, but I kind of like using the product rule here. So specifically, my u is x squared plus 4x plus 4, and my v is x minus 1. So my u prime is going to be 2x plus 4, and the derivative of this 4 over here is constant, that's 0. V prime, the derivative of x with respect to x is just, well, 1. And the derivative of negative 1 is 0. So now, to evaluate f prime of x, I'm going to do the product rule, u prime v plus uv prime. So now, we've got 2x plus 4 times v, which is x minus 1, and I think I'm going to have to FOIL this out. All right, plus u, which is x squared plus 4x plus 4, times v prime, which is 1. Okay, so I'm going to get a little bit exhausted, but no worries. I've got colors. So I'm going to FOIL out the left pair of binomials, leaving me with 2x squared, 2x times x is 2x squared. 2x times negative 1 would be negative 2x. 4 times x is positive 4x. Oh, wait, I forgot to put the... And then 4 times negative 1 is negative 4. Then, well, x squared plus 4x plus 4, that just gets multiplied by positive 1, so nothing really changes here. Now let's pair them up. When in doubt, I could just put a 1 right there. So now I'm going to pair up 2x squared and positive 1x squared, combine those like terms and get 3x squared. And then negative 2x combines with positive 4x, combining to make positive 2x. Oh, wait a minute. Combine combine that too, and that should be positive 6x. So that should be 3x squared plus 6x. And then, negative 4 and positive 4 are going to eliminate each other. Okay, now I'm feeling good. So now my f prime of x is equal to 3x squared plus 6x. And now my f double prime of x, that took a lot of work. F double prime of x should be 6x plus 6. Oh, thank goodness it didn't take that much work. So now that I've got my f prime of x and my f double prime of x, let's go. So I'm going to set f prime of x, which is 3x squared plus 6x, equal to 0. Now let's factor out the GCF. What can I factor out of 3x squared and positive 6x? I'm going to factor out a 3x. 3x times what is 3x squared? That would be another x. 3 times 1 is 3. X times x is x squared. 3x times what is 6x? That would be positive 2 is equal to 0. Now, I can figure out the critical points. Specifically, I split 3x equal to 0 and x plus 2 equal to 0. So my critical points are located at x equals 0 and x equals negative 2. And now, I use the second derivative to determine whether my critical points are going to be local min, local max, or, worst case scenario, inconclusive. So my f double prime of x is 6x plus 6. So I'm going to plug my critical points into the second derivative to test it out. Let's start with f double prime of 0. Well, how exciting. 6 times 0 is 0 plus 6. So my second derivative is positive 6. So if my tangent line is horizontal at x equals 0, and then my second derivative at x equals 0 is positive, those are the properties of a local min. Horizontal tangent line, and then it rises, that's a local min. All right, then x equals negative 2. Let's plug that into the second derivative. 6 times negative 2 would be negative 12. Let me put the focus back on. There we go, much better. Negative 12 plus 6 is negative 6. So that would tell me that my critical point at x equals negative 2 has my critical point has a horizontal tangent line, and then my acceleration predicts it's about to go down. So those are the properties of a local max. And I always find a safety net with the graph to be much easier. So I'm going to graph literally x squared plus 4x plus 4 times x minus 1. X equals negative 2 is a local max. X equals 0 is a local min, just like our work predicted. So there you go. Got one more, and then I'm going to call it a day. So let's take a look at f of x is equal to x minus 6 quantity to the 5th power. So if I want to take the derivative of this, remember, I got to get that chain rule. The chain rule is going to be key to finding f prime of x. So if this is blah to the 5th power, that's going to be 5 blah to the 4th power times the derivative of the inner function blah. So that's just 5x minus 6 quantity to the 4th times 1, or just, 5x minus 6 quantity to the 4th. So that's my f prime of x. Okay. Now, I know it seems confusing. Go back a couple of tests. We had a test on chain rule. I don't care about that coefficient in front. how do I differentiate 5 times x minus 6 quantity to the fourth? Well, I don't want to use product rule. I can. It'd be a waste of time because u prime would be 0. But another way to think about it is, if we factor out the coefficient, all we literally do for f to take the derivative of 5 times x minus 6 to the fourth power is we just pretend that this 5 was just on the outside all along. So let's do the derivative of x minus 6 to the fourth power. That'd be 4x minus 6 to the third, and then the derivative of x minus 6 prime, x minus 6 prime would be 1. So just to shorthand it, that'd be 5 times 4, which is 20, and then x minus 6 to the third. So now that I've got everything in one place, even though these aren't the answers, I find color helps me focus. So I care about this f prime of x function and this f double prime of x function. Okay, now then, just turned into taking derivatives all over again. That whole test on chain rule, product rule, quotient rule. I'm a little overwhelmed. But where were we? Oh yeah, the whole point of derivatives is to calculate slope. In particular, I care when the slope is equal to 0. The slope is horizontal. So 5x minus 6 quantity to the fourth power is equal to 0. Let's solve for x by dividing both sides by 5. I still get x minus 6 quantity to the fourth power is equal to 0. Well, I mean, come on, I'm just going to use common sense at this point and just say, hey, the critical point is located at x equals 6. Then I'm going to use the second derivative, which is 20x minus 6 to the oh, I can see where this is going. This does not look good. F double prime of 6 is 20. Oops, there we go. Come on, nope, there you go. Clean that up a little bit. So if I plug in f double prime of 6, I get 20 times 0 cubed. Or, well, 20 times 0 times 0 times 0, that'd be 0. What does that mean? It means that it's a horizontal tangent line at x equals 6, and then I have no idea what that means. So it is a critical point, but it's inconclusive as to whether x equals 6 is a local min or a local max. In my opinion, it's neither, because if I were to zoom out on this graph, look at that. So it starts to rise, flattens out for a long period of time, it looks like. Even though it's a tiny little decimal, it's very, very small, and then it rises again. Rise, flatten out, rise again. That's not a local maximum nor a local minimum. Hope you guys enjoyed this video.